Hi guys, welcome back. So we're going to do a lesson now on the quadratic formula. And the quadratic formula is a formula you can use to solve quadratics when you can't factor them or you can't graph them easily. So first of all, solving a quadratic means to find these zeros or the roots or the x-intercepts. They all mean the same thing. And to solve these quadratics when they're graphed for you, it's super easy. You just state the x values of the x-intercepts. So that's x equals 0 and x equals 4 for the first one. Right here, it's just one answer. So there's x equals -1. And here there's no x-intercepts, so there's no solution. Okay, that's not so bad, right? By graphing, just look where it crosses x. If we are factoring, well, we need two numbers that multiply to make -12, but add to make +1. And that's going to be +4 minus 3. It's an arrow, not a minus, so it's +4 minus 3. And when there's no leading coefficient, that's just a 1 there, then we can just pop these numbers into the brackets. So x plus 4, x minus 3 equals 0. And then solve each one individually. So x plus 4 equals 0 gives us x equals -4. X minus 3 equals 0 gives us x equals +3. There's our two roots. Sometimes you have to rearrange first. So let's move the 10 to the other side. So it becomes 2x squared plus x minus 10. And then we find two numbers that multiply to make the product of 2 and -10, which is -20. But they add to make +1. And so that's going to be +5 minus 4. And so I split the second number, the x number, into +5x minus 4x minus 10 equals 0. Factor out what's common from the first two, what's common from the second two, and so on. So x is common to the first two, so I get 2x plus 5. -2 is common to the second two, so -2, and I get x plus 5. 2x plus 5 equals 0. These binomials have to match, or we're doing this all for nothing. So 2x plus 5 is one factor, and x minus 2 is the other. And then solving each one, this will give me minus x equals -5/2. And this one will give me x equals +2. And there's my two roots. Yay. Sometimes you may have to do common factoring. So here this is a 4x is common to both, leaving me x minus 2. And so this first one gives me x equals 0 as a factor, and the second one gives me x equals +2 as a factor. So these aren't so bad. +10 and -10. You can figure that one out yourself. So we can use a formula to find this, and the formula is, I'm going to link a YouTube video that has a really annoying version of this song sung by some kids to the tune of Pop Goes the Weasel, but it's x equals -b plus or minus, that's how we get two answers, one's plus, one's minus, the square root of b squared minus 4ac all over 2a. And I'll make you sing the song when I return. So notice b squared minus 4ac kind of tells us if there's one, none, or two roots. Because if this whole little thing turns out to be negative, then you can't square root it, so there's no answer. If it turns out to be positive, then you can square root it, and then the plus case is one root, minus case is the other. If it turns out to be 0, then adding or subtracting it makes no difference on the answer, so that's when you'd have 1. So it's greater than 0, 2 roots. Equal to 0, 1 root. Less than 0, no roots. So b squared minus 4ac greater than 0 gives us 2 roots. If it's equal to 0, we get 1 root. And less than 0 gives us no roots. And that's how we're going to actually use this. So a, b, and c. What's a, b, and c? Well, that's when it's y, or 0, equals ax squared. So a is the number next to x, plus bx. B is the number next to x. A is next to x squared. B is next to x. Plus c is the one with no coefficient. So no factoring needed, just record what A, B, and C is. Be very careful about bed mass and go to town. So let's try an example before we run out of time, and then you'll have some time to practice. There's an application problem that we'll take up on another day. So here I have A is 18, B is 9, and C is negative 35. It's important to take the negatives with you. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so plugging this all in, I get negative 9 plus or minus the square root of 9 squared minus 4 times 18 times negative 35 all over 2 times 18. So I need a calculator to solve this. So I'll just quickly call up my calculator. And I'm going to start with what's inside the brackets first. So 9 squared minus 4 times 18 times negative 35. So that's 35, and I'll make it negative. If I do subtract 35, it'll get all weird. It doesn't work out properly. So that is 2,601. So it's negative 9 plus or minus the square root of 2601 all over 2 times 18 is 36. And so my two answers are going to be, well, what's the square root of 2601? It's 51. So my two answers are going to be x equals minus 9 plus 51 over 36, or my x equals minus 9 minus 51 over 36, which works out to, well, this is negative 100 over 36, which is about, sorry, negative 60 over 36, which is negative 60 over 36. And we just try and reduce this as much as possible. So it's negative 30 over 18, which is negative 15 over 9, which is negative 5 over 3. There's one answer. And the other one is going to be 51, negative 9 plus 51. So that 42 over 36, which is 21 over 18, which is 7 over 6. And there's my two answers using the quadratic formula. If you are missing, that's 7 over 6 here and minus 5 over 3 here. If you're missing pieces, like here, see how there's no number between these two, then you can add it in with a 0 as a coefficient. So this is the same thing as 2x squared plus 0x minus 12 equals 0. So a is 2, b is 0, c is negative 12. Pop it into the formula. X equals negative b, which is negative 0, plus or minus the square root of 0 squared minus 4 times 2 times negative 12, all over 2 times a, 2 times 2. So that's 0 plus or minus, so just plus or minus. The square root of negative 4 times 2 is 8. 8 times 12. Negative 8 times negative 12 is 96. So root 96 all over 4. And the square root of 96 is that. So this is going to be positive that divided by 4. So that's going to be 2.44 approximately. It's x equals, or x is approximately equal to negative square root of 96 divided by 4, which is negative 2.44. Okay, so try and leave it as a fraction if you can, but if you can't, then give me an approximate decimal answer, rounded to 2 decimals. Anyway, that's our video for today. There's some application problems on the next page that you should give a shot. It's approached the exact same way as the previous application problems, only you have to use the quadratic formula to find the roots, midpoint for vertex, and then fill in all the information after you graph. Thanks very much. I'll see you soon.